Well, hello there again, friends. Today is 8/19/2022, and today is the Odin Project Vlog Day 143. And for this video, I completed the Common Data Structures and Algorithms module of the Computer Science section. And I am 58% complete with the JavaScript course. So with that said, let's just get started here. So there's no coding today. It's just a deep discussion about data structures and algorithms. I won't read through all this. It's quite wordy. This is a pretty beefy module, so take your time with it. There's learning outcomes to check your knowledge along the way or to come back to. The assignments, there's a lot of video watching, which is a good thing. Personally, I appreciate it. It helps cement the understanding for me anyway, personally, with the videos, because they do a lot of visual representation of the data structuring and the algorithms, and so it helps understand it better than just reading about it, at least for me. There is some reading in here, but 3/4 of it's videos. All these are videos, video. I will say, if you have not watched these yet and you're just watching my video for entertainment value, number 7's a doozy. So I found it very difficult. Never been exposed to binary tree before, and the traversal process and the algorithms that go with it. So take your time with it. And the videos are really good. They're really in depth. The guy goes slow though, and he does a pretty good. I feel he does a pretty good job of explaining everything. So for the brevity of my video, there is some questions that kind of start touching into binary trees. I'm only going to go surface level with them, and I'll let you know that too when I get to them in the knowledge check, because really, for one, I don't fully understand it myself. I will go back and re-watch these, probably likely when we hit the next project and I start having to use binary trees. I'll probably go back and re-watch these or re-watch the applicable ones. But also because there's no sense in me covering it when he does such a good job anyway. There's no sense to make a YouTube video off a YouTube video. So that's why I've decided not to do that. Here are additional resources as usual, and here's the knowledge check that we'll hit up here. So the first question is, what is the difference between a stack and a queue? And this cues out to a YouTube video that I'm not going to click on, so I'll just read you my notes. The difference between a stack and a queue. So a stack is vertical versus a queue is linear. A stack can you can add, or in our case push, items to an array and vertically in a stack, or remove them with the pop method from the array from the top only. So basically, you can push from the push or pop from the top only. It's a LIFO. It's a LIFO approach, which means stands for last in is first out, or in our case, last element in is first element out. So you can only push or pop, add or remove from the top, and it's first in, first out. You also can't access the middle or any other part of the stack because it violates LIFO, and it doesn't have index values that allow you to access them. So a use case for stack would be like, I think they said in the video, if I remember, I didn't write this down, but I think what they say, adding an undo button in your application is good. It is a good use case for using a stack, because as you know, when you hit the undo, you're pushing and popping from the top of your most recent item put into the stack. So that makes sense. The queue is the other one. It's linear, which means it goes horizontally, and you can add or push from the back only, and you can move or pop from the front only. And that's a FIFO, which means FIFO rule, which is first in and first out. Also, the middle can't be accessed because of lack of index values. So the use case for a queue, I think in the video they said, would be like a deli. Like, uh, I don't know what the use case is, but the idea is like a deli um, uh, idea where you pull your number, you get in line, and then you wait in line, wait in line, wait in line until you're the first in line, and then you get your food. And that's the same approach with the queue. Um, it's a common way to use to traverse through an algorithm, and that's about it. So those are the difference between the two. They're just fundamentally different in the way they operate and the way they access and what they access for data and what order. Second one is how would you implement a queue in Ruby? This goes out to a blog post. Essentially, it takes you out to this article that you read. This one you actually do read in the assignment section. But because we're not working on Ruby, I'm just going to answer it real quick and we'll move on. And it's basically using an array and two methods to get the job done. The array will be used to store the queue, and the two methods would be one to traverse the queue. One would be to push at the back, and another one would be to pop at the front. Since we're going to be using since in this example they're using the linear, the queue linear approach. So you'll be pushing from the back and popping from the front. So one method will be to push, one method will be to pop. Sorry about that. I had to make sure I didn't have that wrong. Number 3, what is a linked list and what is a node list? This goes out to a Wikipedia article. It's pretty good. Again, you do read this in the material. Excuse me. A linked list is basically a linear collection of data elements of any type, and those individual element types are called nodes, where node itself has a value. It points to the next node in the linked list. So basically think of a linked list as a linear queue, and because that's essentially what it is, and then each individual node is the item that has the value in it, and it points to the next linked list node. So that's a linked list is kind of like the whole thing. Think of it as like the whole collection, and then each node is the individual value and the next node it points to. So that's the answer for that, for linked list and a node. What type of algorithm would you use to perform a binary search? Goes out to another YouTube video. So the answer to that is you would use divide and conquer algorithm that we've used in previous videos, and that would be the recursion. And it's assumed that you've already sorted your array. If not, you need to clean the data and sort the array first before you can divide and conquer, because as we've learned and as you know from this reading and from our previous exercise, that divide and conquer won't work if you haven't sorted it first. Like I did in the previous exercise, you can do divide and conquer with sorting through merge sort kind of together, or not kind of, it is together. You can do that as well, but the idea of this particular question is you can use divide and conquer, but you got to make sure it's sorted first. And the last two questions here, this refers to what I was talking about earlier about the binary tree stuff that's pretty involved. So I'm just going to answer the questions. I won't really go into much detail because these also branch out to those YouTube videos, to the sections that answer it. They're not long. They're like 10 to 14 minutes each, but there's 3 of them. So take your time with them. There's a lot to understand with them, and feel free to watch them multiple times if you need to for further understanding and cementing. So number 5 is, what abstract data type would you use to defer or store nodes in a breadth-first tree or traversal? You'd use the queue FIFO data type that we already talked about, the first in, first out, that you push from the back and pop from the front, and That works for the breadth tree. Again, I tempt myself to try to explain it, but I don't think I do a really good job, and his videos really go into detail, in depth on the explanation of that. So I encourage you to go out there. Same thing. Next question: what abstract data type would you use to defer and store nodes in a depth first tree traversal? And that would be using the call stack, which, if you remember from earlier, is the LIFO. The last in is first out data type, and he goes through how that works and how that works through the binary tree. And then he also shows on the other one how that works and how that goes through the binary tree for breadth first for the FIFO queuing. And that is it. So short and sweet today. Next we'll be going into another project, linked lists. So I think we're going to get hot and heavy right away with using these linked lists, and that's probably going to be a queuing protocol, and haven't looked at it, but that'll be what will be coming up probably maybe this weekend. So anyway, hope you enjoyed the video and come along the ride and learned something today. Please like, share, and subscribe for more content, and let me know in the comment section what you guys thought of this module discussion, and stacking and queuing and divide and conquer, and all the data algorithms and data structures and all that jazz. So with all that said, till next time, see ya.